Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator. Today, we're going to talk about the business of being a complete end-to-end spacecraft company that can support all types of space missions. This includes manufacturing readiness, software design payloads, and the challenges to a proliferated space. With me today is Josh Duncan, Business Development Specialist at Blue Canyon. When it comes to commercial space, we are starting to see fewer experiments and more operational missions. The Renaissance area of commercial space is here. Wouldn't you agree?
Yeah, I would definitely agree, and that's something very exciting for Blue Canyon that we've been kind of preparing for the last 5 years or so.
I like the word renaissance because it means rebirth. And I guess the implication is that in the 60s and 70s, this was a hotly contested world, and it's kind of gone into remission. Now it's being rebirthed here in the 2020s, isn't it?
It really is. I think one of the exciting things is that the commercial marketplace has allowed for a lot more players outside of the traditional government players to reap the benefits of participating in space.
The space industry has been witnessing a significant paradigm shift with the adoption of small satellites and constellations over larger legacy spacecraft launch in smaller quantities. What's causing this shift? Do you see it continuing?
Yeah, that's a great question. I think that, I'd like to say that SmallSats are completely taking over the world because I'm, a player in that realm. I think there's still a lot of room for other regimes and large spacecraft as well. But I think what you're seeing is the value of proliferation in LEO is really being demonstrated in the marketplace right now. One of the examples that comes to mind is, there's always going to be use cases and business cases for MEO and GEO-based large spacecraft, but the economies of scale available and the price points available in LEO are really changing the art of the possible. You're starting to see the price points and the quantities available and the scheduled durations, and as those all come down, people are actually coming up with more nuanced and more unique heterogeneous architectures that weren't really a viable trade in the past. I think one of the things that you see is that it takes kind of all pieces of the ecosystem for that to happen. If you have, for instance, a commoditized bus like BCT provides, but there aren't corresponding payloads available, or there isn't a sufficiently affordable and high cadence launch capability, then you really don't have an architecture. But what we're starting to see is all those pieces are now coming together, and so you're getting both a cost-effective, agile, and really powerful proliferated solution out the end of that supply chain.
There's another phrase that's used in your world is called manufacturing readiness. So when it comes to manufacturing readiness, we talk about small satellite systems, and this whole concept is very attractive to the military. Can you talk about what it means to proliferate and be replenished to support strategic military missions?
Yeah, for sure. So I think one of the keys with manufacturing readiness is that we're beginning to leverage commercial and commoditized products that are highly mature. And what that buys you from a cost and schedule perspective is the ability to get a series of capabilities on orbit quickly. And then you mentioned replenishment, and so that's one necessity, especially as you start moving towards components that are more 2 to 5 years lifetime. You're going to have to replenish. But the other thing that I think is really exciting for people like us at BCT, but also the end mission users, is the ability to do technology insertion. So at every opportunity, whether it's a replenishment opportunity or a planned tech insertion, you are actually adding capabilities to the constellation. So to me, that's one of the powerful ideas of proliferation in LEO.
Josh, I live in the Washington, D.C. area, and everything here is an acronym. And so when you tossed out BCT, I was going to go to my DoD reference guide and think like what that was. But BCT just refers to Blue Canyon Technologies, right?
Yeah, correct. Yeah, I apologize. I'd love it for BCT to be in the DoD acronym list, but I don't think we're quite there yet.
Well, yeah, I'll just go down the street and talk to some general and have them slip that in there. Let's go back to talking about satellite systems. I mentioned manufacturing readiness in small satellite systems. So can this strategy replace a big satellite mission?
Yeah, to me, replace is a big word. I think there are use cases where that truly makes sense. For years we've been thinking about how do we replace the big juicy targets with a set of disaggregated satellites that provide a similar capability, but are harder to defeat. And so I think that's certainly one piece. As I mentioned before, I don't think it's a complete remove and replace, but it's more about looking at a creative architecture that employs multiple different classes of assets, even potentially in different orbital regimes as well, and using those as a collective to deliver an end product out the other side of the pipeline that takes the best assets and the best artifacts of each one of those design and architectural choices and melds them together, which is both exciting but also certainly a challenging architectural nut to crack.
I think you just define the term you used earlier, use the term heterogeneous. And that kind of is exactly what we're talking about here, is that best of class mix and mash and whatever it takes to actually accomplish the job, doesn't it?
It really does. The idea of augmenting what's already there, as well as considering the best approach for what assets to use to replace aging assets. That's a pretty dynamic trade space right now, and we're excited to be a part of it at Blue Canyon. And I think there continues to be room for the traditional players as well, and there's a growing competition which keeps us all on our toes.
You know, Josh, I facetiously mentioned the DoD, but it's 5 miles up the road from me here. So are there defense organizations that are adopting small satellite systems for missions?
Yeah, I guess I hesitate to speak for the Department of Defense, but I think we do see those indicators. One of the things that's out there in the public domain is just the architectures that SDA is pursuing, and I think that's a clear kind of market indicator in and of itself. And I think we're seeing similar things in the civil and commercial realms as well, where the value of small sats is transitioning from solely a demonstration capability to recognizing the value of the data and products coming off of those demonstration missions, and really validating that this is a valid architectural choice to make in the operational realm. And so that shift, it takes place at different cadences, perhaps in those various verticals, and even within different organizations within the DoD. And so we're kind of excited to watch that adoption curve take place, at its various cadences, and be ready to provide those high performance solutions when each organization is really ready to make that adoption.
Well, Josh, I did my homework. I looked you up on LinkedIn. You've got a degree in engineering and you got a certificate in software development. So it seems like you're the perfect person for me to ask this question to. So what is the importance of a virtualized test infrastructure to support this manufacturing readiness?
Yeah, that's an interesting question. To me, the manufacturing readiness ultimately is a multidisciplined problem, right? You need a solid design, on the hardware side, but also on the process side, on the procedure side, supply chain, all that needs to come together. And otherwise you don't end up with a true rate manufacturing, a mature environment out the other end. And so I think to the extent that virtualized tools help, arrive at those designs and processes, that's really important. I think at the end of the day, though, you also can't beat the experience of having actually executed manufacturing and uncovered the problems that are bound to occur and develop strategies to solve them. So that experience and been there, done that to get to that heritage is also really important. When you talk about the virtualized infrastructure, I think they're interesting implications on the design of a spacecraft as well as a design of a test environment for sure.
I'm sure the military is looking at flexibility and being able to test things ahead of time before deploying them. So I imagine this whole idea of simulation and virtualized tests is something the military has been discussing. Is that correct?
I think we've been beginning to see that in the various solicitations. We're beginning to see terms like digital twins. We're seeing interest in model-based engineering, and then we're also, the Space Warfighting Analysis Center, for instance, has been stood up. And to me, that's a little bit more looking at the big picture architecture and how you lace all these disaggregate resources and data sources together. I think that's a really tough nut to crack, and I think that's a key area where modeling is going to play a big role, across the industries. And it's been interesting to see that the government in that case is beginning to welcome industry into evaluating that trade and threat space in order to solve these problems at a kind of an operationally relevant timescale compared to potentially the more traditional development life cycle that has been in space to date.
Josh, thousands of people from all over the world have listened to this podcast. Go to Google and type in Constellations Podcast to get to our show notes page. Here, you can get transcripts for all 100-plus interviews. Also, and sign up for free email notifications for future episodes. Well, Josh, I'm going to ask you to take off your mechanical engineer hat and put on your software developer hat. Software-defined satellites are becoming available for larger satellites that will be placed in MEO and GEO. So what about these small satellites we've been talking about?
Yeah, that's interesting. I really don't quite have a very robust software development hat, but I have built a lot of ground architecture, and one of the interesting things there is, as you mentioned, the idea of a software-defined satellite, I think, has its roots in what happens in ground-based IT, and so a lot of those technologies are now accelerating into the space domain as well. One of the forcing functions in my perspective is the fact that a lot of the actual hardware that we're beginning to deploy, especially in smallsats, has its base in ground-based IT, and we're starting to adopt actual hardware that's very similar in a way that isn't traditional, and so that's accelerating some of those techniques. So when we talk about a software-defined satellite, to me, you want to start robbing the best of what we've discovered in data centers, where virtualizing the compute and virtualizing the network, virtualizing the storage, allow for a more flexible deployment of your technologies, as well as kind of an optimization of them. You're using the resources that you have as fully as you can, and you have the opportunity to adjust once on orbit, which has traditionally been a really kind of a scary thing. Luckily, BCT, even at the hardware level on the bus, we've always kind of had that mindset of providing flexibility there. And then I think it extends as you start putting high performance compute and storage on top of a bus. We have Seeker, for instance, in the Raytheon family, providing those functions. And then you start thinking about payloads. Instead of deploying their processing on hardware, they're virtualizing that processing as well, which allows them to adjust to the threats, if it's a DoD case, or to the adjusting science needs or commercial needs once on orbit, which I think is part of what makes this idea of a software-defined satellite really exciting.
So when we compare satellite sizes, are there any advantages to having a small satellite? Does it give you any opportunities that you can't with other ones?
I think one of the advantages we are really seeing is, as we've standardized our platforms, the ability to take something pretty close to off the shelf and deploy it certainly has its benefits. Obviously, the ability to rideshare and the commitment across, the commercial launch industry, as well as the government's commitment to providing rideshare opportunities where the large primary mission provides additional space on their launch vehicle to host missions. Again, it follows this same trend we're seeing, the same tone, which is provide the agility to react to needs in the industry, in the Department of Defense, in the science community, get them that capability up on orbit as quickly as possible. And so smaller is, in a lot of ways, easier, just in some of those logistic areas.
Well, I want to bounce back to the DoD. Just up the road here is the Pentagon, and there's a metro stop there, and see all kinds of people in uniforms getting on the train there, that's for sure. And I want to focus back on the warfighter, those guys getting off the train. So we talked about the small satellites and software-defined small satellites and flexibility. And so how can one of these, software-defined small satellites help the needs of one of these warfighters?
Well, I think one of the things that you see SDA looking to address is there's such an incredible number of disparate assets, even on the ground and in the air, that all need to communicate, and that networking has traditionally been done in a number of stovepiped programs. And so the idea of lacing together commercial capabilities, DoD native capabilities together, and providing the best network possible is a challenging space and ground-based architecture to embark on. But I think it's an important one when you talk about the resiliency required and the ability to get the important pieces of data to the end user as quickly as possible.
Earlier in the interview, we mentioned a proliferated space, and so many people may be listening to this and saying, well, what are the key challenges to a proliferated space going forward for commercial versus defense? Yeah,
that's interesting. I guess I like to look at the opportunities versus the challenges, but yeah, the challenges are there. They're certainly real. From the perspective of the technology adoption curve, we are early in many domains, and so there's some of that organizational and architectural kind of inertia in each one of these verticals that needs to be broken down. And so I think those are slightly different in the commercial and the DoD paradigms, but they're still there and they're real. We're trying to be really proactive and ready for when some of those log jams break free. So I think that organizational challenge of just adopting something new, it shouldn't be discounted. And then there are certainly technological challenges as well. There are, I think, a mix of expectation and reality challenges as well. When you think about new space, as I'm talking to people, often there's this expectation that there's an easy button. Now everything's small and fast and easy, and it's also super high performance and super cheap. And so it's kind of navigating. Those are still all trades, and there's not one right answer for everyone. And so we're really looking at providing the right technologies and flexible solutions that can be kind of quickly adapted to various use cases and customer concerns, and kind of walking customers through different ways to approach their needs. Reliability has traditionally been, for instance, accomplished through the types of parts you use and redundancy within the spacecraft. Now you can consider things like maybe I use redundancy at the constellation level versus at each individual piece of hardware level. And so some of that is kind of a give and take with the providers of payloads, with the providers of buses, with the people who are dreaming up these architectures, and all those are coming together. So some of these challenges are soft challenges, and versus actual the challenges to deploying hardware. But of course, as I mentioned, the whole ecosystem has to fit together, and all the parts and architecture and launch and comm all have to fit together in order to get an end product out to the user in that kind of responsive time frame that I alluded to earlier, which is really what we're trying to solve, is get capabilities on orbit at the performance level and the reliability level that the end user needs.
Josh, I think your company recently had several components successfully launch aboard a mission. I think you folks provided reaction wheels and an integrated altitude control system. So what are those components and why would they be important to a launch?
Yes, it's really fun. I mean, that's at the end of the day what I show up for every morning is to be an enabler to get our customers' capabilities on orbit. And so we are providing those turnkey buses, but also turnkey subsystems, as you alluded to, and individual components as well. And that's been one of the exciting things about BCT is the diversity of missions that we're able to support because of that approach. So on any given rideshare launch, we often have all of those all the way up and down the stack, a turnkey bus when it makes sense for our customer, but when they have a unique mission and bus design that doesn't necessarily align with one of our standards, we're happy to sell them a high-performance turnkey navigation and attitude determination and control system. And so that kind of vertical integration that we offer gives us the ability to also bring products to bear to the market at each tier of that value chain. And so, yeah, I mean, we just recently launched, as far as I'm aware, one of the first CubeSats to GEO. And then on the same launch, as you alluded to, there's individual components manufactured by BCT going up as well.
Well, Josh, you gave a great interview today. Really appreciate your time. And I just want to thank you for giving our listeners a better understanding of concepts like proliferated space and disaggregation. I'd like to thank our guest, Josh Duncan, Business Development Lead, Blue Canyon Technologies. Thanks, Josh.
My pleasure. Thanks.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.